And we're back for part 2 of my series where I try to build an affordable and repeatable system for turning all of this into this. The first video really took off, and I was thrilled to see that you guys care as much about this project and about the potential environmental impact of it as I do. By the way, if you haven't already seen the first video in the series, you can go ahead and click on it up here to open it in a new tab so my algorithmic overlords over at YouTube don't penalize me for low engagement. Anyways, since the last video, I've been hard at work, and I have a lot of hard-won lessons and updates to share. Some good, some bad, and some very bad. So let's get after it. So let's start out with probably the biggest area of headaches thus far, which has been the framework and welding lessons. As soon as I hit publish on the last video, I got back to work on my welded frame, if you can even call it that. As mentioned in the last video, I needed to build up some kind of motor mount to adapt the motor that I have to my proposed setup, which did not include a gearbox with a flange. More on that later. As well as I needed to add some bars in the back to kind of space the whole thing away from the wall and compensate for the trim piece near the floor. This took quite a bit of time to get right, especially drilling into the steel, since I clearly did not have the right drill bits. But eventually, and with a little bit of help from a friend, we got there. While I was at it, I also took the time to add cross braces depth-wise on the legs and a simple shelf width-wise, both to stabilize things and to hold the bins under the shredder. However, as a lot of people pointed out in a bunch of super helpful comments, thank you by the way for all of those, I was doing a lot of things wrong. First of all, I was not properly cleaning and grinding down the surfaces, which was then resulting in frustration, inferior quality welds, and very poor strength. Some folks even went so far as to predict that my frame probably would fall apart the minute I turned the motor on, which, judging by the fact that one bump against the wall knocked off the spacer piece, and the fact that the motor slipped right out of the bolts when I lifted the entire thing up by the motor, yeah, they were probably right. What's more, I didn't know at the time that I needed to be wary of galvanized metals, because apparently if this metal that I'm working on is galvanized, then I'm inhaling some seriously toxic fumes. I really appreciate you guys looking out for me in the comments, and I absolutely love that we are learning together and doing this project as a community. It is so cool to me. Now, another thing that many of you mentioned that I probably should do is do this whole project with a MIG welder. So at the time of recording this, I'm actually looking into getting one. Hint, hint, if any sponsors out there maybe want to work with me on the next video. At the outset, I thought that buying and using the cheapest kind of welder out there, one that you could easily get for like $79, is what would make this project more practical and repeatable for all of you at home. But in truth, from what many of you have now told me, it probably would actually be easier and more realistic for absolute beginners to use a MIG welder, even if it means that you'd probably end up renting it instead of buying it. Either way, I really hope that the welding component of all of this is not what's going to stop anyone who would otherwise attempt this project, because I'm still really enjoying learning how to weld, and I wish that I'd gotten into all of it sooner. So let me know in the comments if you'd like to see more projects that integrate welding. I'd love to do them. In any case, MIG welders versus stick welders, that's all a bit off topic, and the fact that I chose one over the other doesn't even matter, because from the looks of it, we're actually going to have to redo a huge part of the frame anyways. Why is that, you might ask? Well, because again, judging by the comments and private messages from a bunch of people far more qualified than me in this area, I am going to need to change the drivetrain setup. It seems like the whole vertical frequency drive thing isn't going to work out after all. As many of you in the comments helpfully pointed out to me, and as I kinda sorta suspected in the last video, lowering the speed of the motor electronically does not increase the torque. And as you'll see in just a moment, the resulting torque would be nowhere near what we need to shred even the thinnest of parts, not to mention very thick ones like the ones I use later on in this video for the extruder setup. Basically, after reading through all of your comments, I came to the conclusion that I needed a gearbox, and that I'd bought the wrong motor, and that I probably had wasted money on the VFD as well. This might seem like it's not a big deal, so I wasted a few days and possibly a couple $100 here or there so that you don't have to. I mean, after all, the beauty of being a content creator is that the journey, the entertainment value, and most importantly, the lessons I'm able to learn and then pass along to all of you are all far more important than whether or not I get things right or wrong on the first try. And while all of that is true, I was pretty devastated in the hours after uploading the video, despite the video getting really great reception from all of you. At that point, I had spent literally weeks planning, designing, sourcing, welding, taking everything apart when I did the welding wrong, and then welding things back together again. I drove hours to go pick up the motor, and then I purchased all kinds of components for it. I even designed and ordered CNC couplers from PCBWay, only to find out that a fixed coupler was going to be a big no-no for this type of application. Basically, every aspect of my proposed setup and execution up until that point was all wrong. And in the end, all I had to show for it was some learning and a video. I'm not gonna lie to you guys, I was super bummed, and I'll get into how things miraculously turned around in just a second. But first, I think that's actually a really good segue into telling you about this video's sponsor, which is BetterHelp. As individuals, and especially as people who love to create things, we're bound to run into some roadblocks, difficulties, and frustrations in our lives. That's just part of life, and as you can tell from this project so far, it's also a big part of any project as well. But for me, one of the reasons that I'm able to persevere, keep my head up, and stay positive when things go south like this is because I've done and continue to do a lot of personal development work, including, most crucially, therapy. Therapy has helped and is still helping me understand how, for example, different elements of my personality, my childhood, or my past trauma are influencing the way that I show up in situations just like this. And that understanding of myself has given me the ability to kind of pause and take a step back and say, wait a minute, I know why I'm reacting like this, and it's not how grown-up Jonathan wants to react. Actually, funny story, and this is a true one. When I was still single and I badly wanted to get into a healthy and happy relationship and hopefully start a family, I actually used BetterHelp to work through some issues that I kept having. And my therapist at the time helped me understand how some of the different beliefs and behaviors I had were preventing me from actually finding the right person. And a short while later, I met my now wife, and thanks to the advice of that therapist, I actually didn't blow it this time. So I mean, that's worth a rave review from me. So if you're struggling, or you just want to be a little bit more resilient and deliberate when faced with setbacks, I encourage you to consider therapy with our sponsor, BetterHelp. By visiting the link in the description or going to betterhelp.com/thenextlayer, you'll actually get a 10% discount off your first month, where they'll match you with a licensed and qualified therapist, usually within 48 hours, who will then work with you on your specific needs via text, video, phone call, whatever works for you. And if you aren't happy with the match, you can even request someone new until you are. Like I said, I've had a great experience both with therapy and with BetterHelp, and I'm really grateful to have them as a sponsor. Anyways, after a couple of hours of stewing in frustration over wasting my time and money, I actually received a bunch of messages on our Discord server from all of you guys, which really lifted my spirits and provided a glimmer of hope for two different reasons. First of all, I was reminded of just how amazing of a community we've built around this channel, that people would actually reach out and offer to spend their time dropping by the studio and helping me improve my welding technique. And I just remembered that I wasn't alone in all of this. We are all doing this together as a community. But second, one local subscriber, a sort of mad scientist from Haifa named Daniel, actually reached out to let me know that he not only had the exact right kind of worm gear box for this project, as you can see here, but that he would be interested in trading it plus some cash for that second precious plastics kit that I was trying to sell. That's two birds with one stone, and I love it when the universe lines things up for you like that. So over the weekend, while I was actually already in Haifa to visit my in-laws, I met up with him both to pick up the gearbox and exchange it for the shredder, and get some tips on welding while I was at it. So together, we strategized on the best setup moving forward, whether I should trade him motors or use a belt drive, and eventually we decided on my existing triple phase motor and one of the gearboxes that he had lying around in his shop. Now, it wasn't easy, but after a lot, and I mean a lot of prying, we actually managed to free that gearbox from the original drive shaft that was already embedded in there, at which point we traded. Now, to keep the accounting simple, I sold him the extra precious plastic shredder kit for 1,700 shekels or $463, and then I bought the gearbox from him for 500 shekels or $136. Now, I just need to order 2 more pieces to make this gearbox work with the motor that we already have. First, I need a sleeve to adapt the 20mm drive shaft of the shredder into the output of this worm gear. And second, I need an adapter flange to actually connect the motor with its massive 200mm 4-hole flange to this tiny 97mm 6-hole flange of the gearbox. Now, to get both of those things done, I whipped up Onshape and I began designing them from scratch. Yes, I am pretty sure that there are off-the-shelf solutions available for both of these things, but I spent about an hour online looking for them and I couldn't find someone who could get them to me easily and quickly. And plus, PCBWay is a long-standing sponsor and partner, and they've agreed to hook me up with some custom CNC parts for the next video in this series. Now, as to whether or not I should include those expenses of the CNC parts into the final cost breakdown, we'll see. Because in all truth, the big takeaway from this whole experience is that if you're doing this at home, you should buy a secondhand motor and gearbox combo together, which are already adapted to one another. Ideally, just check out your local junkyards for deals like Dave did in his own assembly videos, but make sure that you get the gearbox with it. That'll not only save you money over purchasing each of them separately like I did, but it'll also mean that you don't need to worry about designing or paying for adapters like I'm going to have to. Before the next video, I do hope to do some research and figure out how much a combo like that would cost one of you secondhand, so that we could do the accounting as a cost to recreate calculation without all of my mistakes and unnecessary expenses along the way. So stay tuned for all of that. By the way, one thing that I think is really important and worth noting here about 3D printing, because this is a 3D printing channel, before I ordered the CNC parts, I did 3D print my own designs to test out the fitment using a Diamondback nozzle that US Synthetic provided and PETCF filament for both strength and dimensional accuracy. But I was actually blown away by just how far off my dimensions were. So Daniel, who has way more experience with machining and steel and gears and stuff like that than I do, let me know that the standard tolerance for these types of applications is 0.05 millimeters. So I designed and printed the parts with that tolerance, but they didn't fit, like not even close. And to give you an idea of just how much they didn't fit, the 7.95 millimeter key slot from my design actually came out as 8.5 millimeters. That's partly because of the pressure advance issues on the corners with PETCF, which wasn't calibrated for that printer. It's partly because of the 0.6 millimeter nozzle, and maybe even because of the texturing on the outside of the carbon fiber filament. But it was really interesting and eye-opening for me just to see how different the levels of accuracy are between the prototyping technology, 3D printing, and machining. Personally, I just sanded things down to the dimensions they were supposed to be so that I could at least test things out. But if any of you out there actually have any resources or suggestions on using 3D printing to get accurate enough samples to test out before something as precise as CNC machining, I'd really love if you share them in the comments below. I'm curious if next time I should design 2 different versions of the parts, one with 3D printing tolerances and one with CNC machining tolerances, or should I just make adaptations in the slicer when I test the prototypes, or what do I do there? Anyways, for the sake of science and for thoroughness, my electrician friend Mohammed and his electrician friend Roman and I all decided to run all the triple phase wiring that we were going to need and then rig up the VFD and the motor anyways, directly connecting them to the shredder using a 3D printed coupler. As I'd originally intended, just to see what would happen. And as predicted by those helpful folks in the comments section, we were able to get slow enough speeds, but the output wasn't nearly powerful enough to shred even the thinnest piece of a failed 3D print. Not to mention that the fan of the motor was moving way too slow to actually cool the motor. We then compared that setup to the strength of the output with the worm gear, and we were actually surprised to find that with the right gearing in place, we were now able to shred plastic even by hand turning the input of the gearbox. But when we went to actually test, as you can probably predict, my 3D printed fitment sample coupler just snapped right in half. So before we continue with the shredder build, we will have to order the CNC pieces from PCBWay and rework the frame to now fit the worm gear and mount that up. And then we're gonna have to raise the gearbox to match that height. So at the risk of kind of jumping around too much and making this video a bit hard to follow, let's switch gears, no pun intended, and see if we can work on another part of the build while we wait for those CNC parts to actually show up. After all, shredding the failed prints is only one part of this equation. We'll then need to find a way to actually extrude that regrind into usable filament. This is more challenging than you might think. You see, the majority of the solutions out there are both extremely expensive and designed for extruding plastic pellets, which are both round and consistent. In order to extrude regrind, then, we need a solution which takes into consideration the variances caused by shredding recycled plastic. And in order to come within our budget, which I'll remind you is $1,500 or less, we can't really rely on any commercially available, readily built extrusion solutions. We're gonna have to build it ourselves. Fortunately, the clouds aligned recently, and Stefan from CNC Kitchen introduced the world to the ArtMay 3D Extruder project, which fits our requirements perfectly. In case you missed that video, the ArtMay 3D is an open source project created by a craftsman in Germany named David. In a lot of ways, the project reminds me of RepRap itself in that it's open source and relies on both 3D printed parts and off-the-shelf components. But the most notable thing about the project, for our purposes at least, is that David offers the kit in two different versions. One for extruding pellets and one for extruding regrind. The differences, as I understand them, lie predominantly in the extruder's screw dimensions, though there are certainly some other differences as well. Since we're primarily, though not exclusively, going to be extruding regrind, the ArtMay is a perfect fit for our project. Now, to be clear, the ArtMay isn't cheap. It cost me €669 or $726 of my own money, including shipping, and that was before an additional $91 in import duties that I'm hoping to get back. Tack on 1.5 kilos worth of printed parts, which, although Soval was kind enough to send over some of their super high quality PLA for this build, we'll add another $30 or so to our list of expenses. That's a lot of money, I know, and because this kit is open source, I guess you could self-source some of these parts from China or design a much simpler setup based on it for less. But as I stated in the first video, one of my main criteria for this project is repeatability, i.e., you guys being able to do this successfully at home. By choosing a ready-made kit with solid documentation, actual customer service, and parts that are already guaranteed to work together, I'm dodging a whole host of headaches and potential failure points and getting a product that, at least according to Stefan's video, already works great. And I'd much rather risk going over budget a little bit, but ensuring our success, than ending up throwing this entire project into the trash with nothing to show for it. And after successfully assembling the ArtMay, I have to say that I'm really happy with that decision. First of all, the design of this system, as Stefan said, is quite ingenious, using things like an infrared sensor to judge tension, gravity to control the filament tolerances, and even a swinging arm to spool the filament back and forth on the roll. I could never design something like this myself, and it kind of blows my mind that there are people out there like David who actually can. Second, the documentation is out of this world. Like, it's so specific, it literally has a page explaining to you the difference between the different types of screws or how to do various steps that you're going to encounter later. And then for each step, you actually have a pre-step before it instructing you on exactly which hardware to pull out from which individually labeled box in which individually labeled bag. This is a level of detail that I've never seen before, even on Prusa or Voron build manuals. In fact, throughout the build, I kept thinking to myself that it felt a lot like building a Prusa printer. That feeling was exacerbated by the components themselves. Outside of the extrusion screw itself, which David actually machines by himself in Germany, the ArtMay system uses almost entirely readily available components like stepper motors, generic boards and screens, and aluminum profiles, which will be really great if you ever need to replace any components. Like assembling a Prusa kit, there's no need for things like soldering or heated inserts, but rather standard hardware is embedded into the prints wherever necessary. Yet another way that this kit is similar to a Prusa printer is in the quality and origin of the components. To be honest, I would not have thought twice if the kit had shipped with a fair amount of Chinese components in the box. After all, everything's made in China these days, right? But I was surprised and impressed to see that David has sourced a lot of the materials from Germany. When we spoke, he lamented that he wasn't able to find certain things like stepper motors and control boards locally because no one makes them in Europe anymore, but that still hasn't deterred him from using locally sourced, European-made parts wherever possible. And his attention to detail in that regard is really quite impressive. The CNC milled parts, made in Germany. The wiring, the screwdrivers, the extrusions, even the freaking silicone lubricant and superglue are all made in Germany. You can see why I've started calling this the Prusa of filament extruders. The comparison still holds true when it comes to the actual build experience. I actually had a huge feeling of deja vu from when I built my Prusa MK3S Plus. And that's not just because I printed some of the heat-resistant parts in Filamentec's Prusa Orange ABS. When you build the ArtMay, you're basically building a 3D printer complete with aluminum extrusion frame, heating element, extruder, cooling fans, and electronics. It's just that on the ArtMay, instead of an XY motion system, the stepper motors are used for feeding the filament back up and turning the spool to wind it. And of course, the stepper motor that would normally drive filament into the extruder is actually a stepper motor that's turning the screw to push the shreds into also an extruder. Overall, the build was very enjoyable, much like building a well-documented 3D printer. Like a Prusa machine, it took 7 or 8 hours, and everything was included in the kit except a power supply. I struggled to find an enclosed laptop-style power supply locally though, so I just managed to find one that looks like the one on your 3D printer for 124 shekels or $34.15. It was going to take a few more days for that power supply to arrive, and plus, we can't actually test out the ArtMay until we have some shredded plastic. So while I waited for all that stuff to arrive, I did want to make some progress on the other aspects of the project so that we could really hit the ground running once everything is fully assembled. In that vein, and with a feeling of success now finally under my belt, I turned my attention back to the shredder and set about designing and creating a hopper to mount on top of it. This is important because it would be both impractical and wildly dangerous to feed plastic directly into the jaws of the shredder. Now, I've seen these hoppers made out of steel, but since we already know how talented I am with the welder, I did decide to this time go with wood. I actually found a bunch of drawers from an old closet thrown in the street and waiting for the trash man, so I decided to take a bunch of those and then I stripped off all the hardware, the rails, and all that stuff. And again, I really love that we're building a plastic recycler out of recycled parts that were on their way to the landfill. Then, because the angles were really a bit tricky to get right manually, and because I wanted the hopper to have the maximum amount of volume without protruding depth-wise into the wall, I decided to design the hopper in Onshape, which then allowed me to export the panels to DXF format and cut them out on my laser cutter. I actually thought about creating those kinds of leaves in the design that you see a lot on laser cutting to kind of interlock and join all the corners just right, but I didn't know how the angles were going to work on the sloping part. I really didn't want to spend any more time on it, so instead I resolved to just glue the faces to one another at 90 degrees, which would obviously be extremely weak, and then just design and 3D print a bunch of brackets at the appropriate angles, which once again I did in Soval PLA. The added benefit of this method is that if one of these panels breaks somehow, I can replace it without having to break all the other ones like I would if they were locked together with wood, glue, and joinery. I also designed and 3D printed a bottom bracket, which I then glued to another piece of wood for strength, and then drilled holes in all of it to join it to the shredder itself. And since I already had the laser hooked up, I decided to engrave my new motto onto the front face. If you've made it this far, I would really love if you let me know in the comments if this slogan made you chuckle. The finished result, honestly, I think looks pretty good, albeit a little bit crooked on the shredder, and it is actually really, really strong. I'm able to lift the shredder, which is extremely heavy, up by the hopper. I particularly like how it won't protrude from the wall in the corner of the room, and yet I still have a huge amount of volume inside. So hopefully I can put a ton of plastic in here without needing to feed or babysit the shredder too much. If necessary, I'll design some kind of plate that sits in there, maybe with a weight on top to kind of push things into the hopper. We'll cross that bridge when we get there because there is still a lot of work to be done before we can even get close to shredding some plastic in this thing. Namely, we need to actually sort out all of this plastic. Now, I had already separated out PLA and PETG, but because I was inspired by Recycling Fabric's ability to produce beautiful, rich colors instead of just grays, blacks, or browns, I wanted to separate out specific color groups, at least of the groups that I have enough waste of to justify it. Now, this was a really, really satisfying task. I love doing this kind of stuff. And when I was done, I was left with bins for black, white, blues, and oranges. I'm actually considering, as you can see, mixing in yellow and red scraps with all the orange to see if it will even out to orange. But judging from Stefan's results, I think that the art may not mix the filament shreddings up well enough, and I may just have to stick to only orange waste. Let me know in the comments if you'd like to see me experiment with adding reds and yellows though, to see if we can even it out to orange. Additionally, I got ready for production by reaching out to a local filament manufacturer, Plastics App, who has agreed to sell me small quantities of colored virgin PLA pellets if I need. Now, I don't anticipate having trouble extruding the regrind, that's kind of the point of the ArtMay, but it might be really helpful to be able to mix in some virgin material or just pure, cleanly colored material to improve both the quality and strength of my final product. But we can experiment with all that later. For now, let's talk about what's left to do, what I hope to accomplish in the next video, and the outstanding challenges. Obviously, the most important thing is going to be reconfiguring the frame and possibly re-welding it using all the helpful tips that folks have shared in the comments, both for strength and for the new configuration with the gearbox. Now that's going to require shimming and moving the shredder around, but one way or another, my goal for the next video is to have the frame done, the motor and gearbox mounted and connected, and then all of that connected to the shredder. I'd also really like to organize the wiring, mount it to the frame, and get this external switch box thing working before I hit publish on the next video. From there, I'd really like the next video to mostly be about trial and error, both with the shredder and ideally with the extruder as well. I've heard quite a few people who tried before me say that when it comes to making filament, garbage in, garbage out. So I'm actually really concerned about that for two separate reasons. First of all, my shop is extremely dusty, and I have no idea how much of that dust I'm actually going to be able to get off of the filament and wasted 3D prints, or even how I'm going to go about doing it. Like, should I try and hit the prints with a leaf blower before I shred them? Should I wash the shreds in a mesh bag and let those dry out in the sun? Let me know in the comments below if you have any ideas. Now, the second reason I'm concerned is moisture. Filament, as you know, absorbs water, and a lot of this stuff has been sitting around in the Tel Avivian humidity for a year or more. In order to get good results, I need to dehydrate the shreds. I do have an old oven here, but I'm not sure how accurate the temperature is going to be, and I really don't want to melt my shreds, which is going to be a challenge given how small they're going to be. Alternatively, I have a lot of filament dryers, as you can see, but I'm worried about the shreds flying around in there or, once again, melting. So I may need to make some kind of metal box out of an old strainer or something for all of that. Again, please hit the comments if you have any ideas. And also, while you're down there, let me know. Do Do you think we should include the cost of whatever we use to dry the filament into the overall build cost, or assume that it's like basic tools and assume that most people will already have that? Anyways, those are the goals for the next video. We still have a lot of work to get done, plus a final cost breakdown. So if you want to follow along, please make sure to hit the subscribe button and the bell icon just so you don't miss the next video in the series. Before I do let you go, I do need to take a moment to thank our YouTube members and Patreon supporters, particularly our Nylon and Peak members, Chip Cox, Two Crazy Ketos, Amir Khen, Chris Miller, and Don Arledge. You guys rock, especially when I'm doing projects this expensive and out of pocket. That's all for this week, but I'll see all of you on the next layer.